These are headphones, that's a chair, and that's a crudely drawn cup. You recognize these objects even though you have never seen this particular cup before, and even though it consists of only a few lines, which is pretty amazing if you think about it. We do this at an incredible speed of milliseconds. This is helpful for daily life, but makes studying object recognition quite difficult, since the time before recognition is too short to measure most methods. In our study, we worked around this problem with the help of emerging images. Emerging images contain a hidden object that seems to emerge after a while, which is how we get the name. If you want to find the object, pause the video here because a spoiler is coming up. By using these emerging images, we can keep the stimulus the same while the status of recognition differs. We use these images together with fMRI to study brain areas that are related to object recognition. We focused on the brain areas V1, V2 and V3, which lie in the back of the brain, and the lateral occipital complex, also called the LOC, which is located more laterally. The visual information that is obtained by the eye travels to the back of the brain, the occipital lobe. It first reaches the primary visual cortex, or V1. The information that lies next to each other on the visual field is represented next to each other at the V1 as well. In other words, if you stare at this dot, then these two things in your visual field are represented here in your brain. This is the case for V2 and V3 as well, and is called retinotopic organization. Information about objects is thought to be processed in the ventral stream, otherwise known as the Watt pathway. In general, the further down the ventral stream, the more complex the information that is being processed. Where V1 mainly processes basic features such as lines, the LOC, which lies much further down the ventral stream, is thought to be involved in object perception. Also, the further down the ventral stream, the less clear the retinotopic organization. As said before, we used fMRI scans in our study to investigate relevant brain areas. We showed participants an emerging image and asked them to focus on a fixation dot. This situation is called EI1. We asked if the participant recognized the object. We showed the emerging image again, this time without the fixation dot, so the participant could let their eyes roam the picture. Next, we showed which object could be found. In this way, we hoped to cue the recognition, so that when we showed the emerging image for the last time, EI2, the object was recognized. In this way, we can compare an unrecognized image, EI1, with the exact same stimulus, EI2, with the only difference being recognition. With the help of MATLAB, which was basically this.
Why? Oh, yeah, okay.
We compared activation towards EI1 versus EI2 for the brain areas V1, V2, and V3, and the LOC. Due to the retinotopic organization of V1, V2, and V3 that I explained earlier, we were able to backproject the change in activity onto the stimulus, which looks like this. Warm colors indicate more activation towards EI2, while cold colors indicate more activation towards EI1. These are some of the backprojections that we made. Each plot represents the visual field of one participant for one emerging image. Each column represents one individual. As you can see, we did not find a particular pattern within individuals or within objects. However, these plots nicely visualize what we found with statistics, namely that the V1 and V2 show more activation towards EI2 than EI1. We did not find a significant difference in the LOC between EI1 and EI2. This is surprising, since the LOC is known as an object-sensitive area. However, showing participants the same stimulus more than once has been shown to decrease the bold response, especially in higher order areas, which might counteract the effect that recognition has. This is called repetition suppression and is a complete field in and of itself, so I will not discuss this in detail. This study shows that the V1 and V2, although often considered basic feature analyzers and feed-forward areas, might already play a role in object recognition. The V3 did not show a significant difference. This fits the current literature, which speculates that V3 does not play a vital role in the ventral stream and thus object recognition. Since we strongly suspect confounding factors in the LOC in this experiment due to repetition suppression, we make no strong conclusions on this area yet. The use of emerging images in object recognition is quite unique. With this technique, we were able to find activation in brain areas that may not have been found with other methods. I think that emerging images are a promising method for future studies as well. A video of 5 minutes is, of course, too short to explain everything in detail, so if you have any questions, don't hesitate to send me an email.